Hi everyone, welcome to another class of MBA at Fastest. This is Shubham Jaiswal and we will be continuing our topic from factors. Now, what is a factor? Factor for any n is the number which divides n and leaves a remainder none. That will be a factor. A number can either be a prime number or it can be made up of powers of prime. So if it is a prime number, it will have only two numbers which divides a prime, which divides the number n and will leave a remainder of 0, which is 1 and the number itself. And if it is made up of powers of prime, that is what we are going to learn in the unit factors. Prime number can have only two factors, and if it is greater than, that's what we are going to see in here. Now, how a factors of a number is made? Like any color can be made up of RGB, red, green, and blue as its constituents. Any number can be made up of prime number or powers of prime as its constituents. For instance, let's take 5400. It has the power prime numbers 2, 3, 5 raised to some of its power. So now, how the factors could be made? It is made up of till 2 cube any power of 2, till 3 cube any power of 3, and till 5 square any power of 5. Now you can take any of them as a factor of 5400, or you can take individually from any of the three brackets, or you can multiply, cross multiply. You will have a factor of 5400 in hand, which when divided 5400 will give a remainder of 0. Now, if you wanted to find out the total number of factors, the first process is you need to write the number n in its prime factorization form as it is written on your screen. 2 cube, 3 cube, 5 square for 5400. And now what you need to do is you just need to add plus 1 to whatever the prime power you are taking. Let's say for here 3 is the power of 2, so you add plus 1 in here, it becomes 4. For 3 also it becomes 4, and here for 2 plus 1 as per the formula P3 plus 1 it becomes 3. You multiply this you will get the value of 48, and this you will get 48 factor as an answer. And this is a pure logical way, which is basically what you are doing actually here. There are four ways of selecting from this bracket, which is here. I could either you could select 1, which is to the power 0, either you could select 2, either you could select 4, or you could select 8. Right. So four ways, selecting four ways from here and selecting three ways for here. So this is a direct shortcut. You can, whatever the power of prime is there, you just add plus 1 to this and you multiply them, or you can find the product of each of them. That will be the total number of factors and will be having. Right? Moving. If you want to find the number of factors which are odd, you just do not consider 2. So do not take into account power of 2 as factor. Whatever is left is 3 cube and 5 square, and then you follow the same process, which is this. So what you will have in hand, 4 into 3 will be left. So if you wanted to find factors which are odd for any numbers, just remove the power of 2. For here, it will be 12 factors. Number of factors, if you need to calculate which are even, you take 1 2 out of it. The logic behind this will be what you just, if you take out 1 2, all the numbers which will be left will be an even number. So if you take out 1 2, this 3 becomes 2, and then you follow the same process, which will be equal to, for finding factors, this will be equal to 3 into 4, 3 into cross 4 into 3 again. So this is 9 4 36. So now if you wanted to find an even factor, this will be have 36 factors. So now if you want to find for how many factors 5400 or 5400, they will be divisible by 20. See, first calculate and see for how 20 is made up of. It is made up of 2 square and 5. What you need to do is you need to subtract the power of prime numbers of this from the respective number of this, and whatever will be left, you just follow the same process, which is this one. Whatever will be left will be 2 to the power 1 into 3 cube, as there is no factor of 3, and 5 to the power 1. Now by similarly using this process, this becomes 2 into 4 into 2. This becomes 16. So 16 factors of 5400 will be divisible by 20. This is how you calculate this. Use GIF greatest integer functions after dividing each power by 2. Since you need to find perfect squares, you just divide the prime powers of prime by 2. Here it becomes 2 to the power 3 by 2 will become 1.5, but you need to take greatest integers function, which means the number which is or the integer which is just on the lesser than this or equal to this. So this becomes how much? 3 by 2 is 1.5. So you take 2 to the power 1, 3 to the power 1, and 5 and 2 and divided by 2 will give 1. So you take 1/5 to the power 1. This will give 2 cube, which will be, this will have 8 factors. If you want to find the number of factors which are perfect cubes, again, you need to follow the same process, but just because you need to calculate cubes, you just need to divide the each power by 3. Just now consider, let's say this has n is equal to f. Although we know it has 48 factors as calculated earlier, but let's say it has f factors. If you want to find product of all the factors of n, let's say f factor f is 48. So now 5400 is having 48 factors. Okay, so this 48 factors is what? Basically they are the product of any two number you multiply and it will give 5400, right? So there are 44 numbers, which means there are 24 pairs, of which when you multiply the two numbers it will give the product as 5400. So, and you need to find the product of all such numbers. So definitely there are 24 numbers which you will get as 5400, and the product of that numbers you need to find. So the answer of this question will directly be equal to 5400 to the power of 24. What we have done in here is 24, and how what we have done here is we have just halved the total number of factors we had in our hand. So this is what is written over here. Product of all factors n is n f by 2. That here, how do you differentiate between a perfect square and non-perfect square? I would like to remind again कि a perfect square will always have the number of factors as odd. Like here it is 48 factor, which means this is not a perfect square. If had it been a perfect square, it would have this as 49, 47, 41 as an odd number as total number of factors. Now see, in previous question we calculated the total number of ways it can be arranged, and then we found out the product of all factors, which is raised to the power. In here we have to go just one step before it and just need to find the number of ways. Product of two factors unordered when where variables are not defined is f by 2, and for ordered when the variable is defined it will be total number of factors. We have already discussed this key. A perfect square will have odd number of factors. Let's say it has 15 factors for now. To find number of ways when distinct and unordered, when variables are not defined, what you need to do, you just need to, if you have this you will get 7.5 approximately. Number of ways cannot be 7.5, it can either be 7 or it could either be 8. So in here what we do, we just go one step back, and because it is asking distinct, 14, it becomes 15 minus 1, 14 by 2, and you will get the answer 7. We are not calculating this because this one which is extra is the root of n. So it will have same, let's say for 36 it will be 6 into 6, and since it is asking distinct we are not considering that way. So the for if I ask for distinct, it is f1 f minus 1 by 2. If it is asking for not distinct for 36, we can consider 6 plus 6. So what it becomes, in here 15 plus 1 16 by 2. So the actual formula comes out to be 5 f plus 1 by 2. For ordered, if it is asking perfect square distinct, which means for 15 factor I wanted to calculate for ordered pair a comma b as one value and b comma a as one value, it will be f minus 1. And for if you want to find for non-distinct, it will be equal to f. Directly you can figure it out how it is possible. Okay, we will continue the factors and sum of all the factors this value in the next video. I hope the learning helped you, and thanks for watching.